This question is the 2014 higher level question 2, which shows a child's lunchbox, where in the question we're given the elevation and the plan. And on the cover of it, which is the red line down here, there is a pentagon inscribed in a circle. Part A of this question is to draw the given elevation and plan. The cover of the lunchbox is rotated through 30 degrees about point O, which would be this point here, as shown by the broken line in the plan. So I've indicated that here with this red line. Project an end view of the lunchbox in the direction of arrow A to show the cover of the rotated in the rotated position. So what I've got here is the start of this question. I've put in some of the information, some of the more straightforward stuff that doesn't involve too much construction, just measurements. And what I'm going to put in now is the pentagon. So I've joined my diagonals to find the center, and it's a radius 40 circle. And we're going to create a pentagon. So for this, the internal angle of a pentagon is 72 degrees. So 360 divided by 5 gives us 72. So between the top point up here and the next point on our pentagon is 72 degrees. So we know that there's one vertical, so from up here we can measure down 72 degrees. Draw a line out from the center, and this point here is a point on the pentagon. We can do the same thing then again from the next one. So I'm just going to again measure from the top, so 72 times 2 is going to give us 144 degrees. Again, from center out to that point until it touches the side of the circle, and doing the same on the opposite side. Now there's other ways you could do it. You could take your compass now at this point and measure the distance from here to here. That's one way, 72 and 144. So that gives us each of our points on our pentagon, and we can just join them up now to form that pentagon. So that's this first part, completing the pentagon here inside in the center of the circle. And that circle needs to be darkened in then as well. The next bit that we're going to do is we're going to locate, there's two arcs here that are tangential to each other. So we've got a circle which is radius 12. We have all the positions for that. We have its center point, its distance up and all that. And then we've got a radius 20 arc as well, and we need to work out that one. So I'm going to start with the radius 12 one. So coming in here from the outside 12 mil, because the center, the circumference of this touches this point, this line here, which is out to 20, and the center is up 48 millimeters above our XY line. So this point here is the center of our arc, which is radius 12. What we have down here in the bottom then is a point joining to that circle. So we've got a circle here, radius 12, draw in. What we're going to do now is we're going to draw a circle, draw a tangent to this circle here. This is the point outside that it touches off of. So we can call that point P. And it's drawing a tangent to a circle from a point outside. So standard construction for this, join the center of the circle to point P, bisect the angle, bisect the length of the line. So extend over halfway, so an arc. Again, put the point for a compass then here in the center on the bisector, pencil onto the center of the circle, and swing an arc until it touches through the side of that circle. that gives us this point here. That's our point of contact. And we can join from a point of contact down to point P, and that is our tangent. The next thing that we're looking for is an arc up here of radius 20. That's going to be tangential to this circle here, and also touch a known point. So that known point is in 20 millimeters from the outside, or 15 from in here, and down 15 also. So 15 to here. So our arc is going to touch off of that point. We know it touches off that point, as we can see in the question. So all we're going to do is we're going to add a radius of 20 millimeters to this arc, add 20 millimeters to this, then swing an arc of 20 millimeters off this. With the two arcs cross each other will be a point that is both 20 millimeters away from here and this circumference. So adding 20 millimeters to this one first. So added that onto the outside of that one. Now just taking the measurement of 20 millimeters from this point up here, which is a point that we know is on the curve. That point here is 20 millimeters from this circle and this point here. So drawing this in now. So that gives us the arc there. Now we just need to find the point of contact, so where it's going to transition from one curve into the other one. To do that, you join the centers. So joining the centers of the two arcs where they cross. That point here is our transition point, our point of contact. So it's going to go from one curve to the other, and then just darken them in. So very carefully if you can do it by hand. If not, definitely use your compass. You don't want to lose marks for having it all done correctly, but not very neatly. So that's the elevation complete. The next part of this is to finish out the plan. So I've this started, I've drawn the handle, this in its new, the lid in its new position, but I'm missing the bit off over here on this side of it. So to find that, I need to find this point here, so the extreme edge of this, and then there's also this point up on top. That's going to be an edge for us as well. So I'll start with this one inside here. That's an edge that comes down along. Also passes through here, so there's no hidden detail down there that we need to worry about. And then for the outer point, so a line horizontal from the center till it hits the outside of that arc here, and project that one down also. As all these lines and arcs are tangential to each other, there's no edge that we need to worry about, so there's no additional detail down here in the plan. So that sets up kind of part A of this question. Now we're asked to project an end view. So I'm going to draw the end view off up here on the top right. That's the direction that we need to put it in on. So I'm going to start by just drawing the lunchbox proper before any of it is opened and done with that. So that's lines 45 degrees, or whatever method you prefer. Heights remain the same. And then the handle also. So over to the very edge of the object, then at your 45 degrees, and up into the top section. Now the only other piece that needs to go into this is representing this edge here. So this line and this curve are not tangential to each other, so there's going to be an actual edge there. So if there's an edge there, that means there's hidden detail there. So this line needs to come across here. We can't see it, it's on the opposite side, so it's hidden detail running along this point. Okay, so that's this first part. The next bit now that we're going to do is we're going to do the part B, which is to draw it in its rotated position. So the first thing that we're going to do inside this question is just find the door itself. So the door is based on this rectangular shape. So again, each point and every point is going to work the exact same way now for the remainder of this question. Find a point up here in the elevation, project it into the original end view, or sorry, the original plan. That's this line down here. Rotate it onto the new plan, which is the red line, and then project it from the new plan into the new end view. So we've found these points already, so it's just within this rectangular piece that we're taking. Project it down here, rotate it around, and now project this over onto the extreme edge. Just get rid of a line that will confuse me. Taking this line over to here, 45 degrees from there, and then vertical. So all of this shape now should fit in within that space there. So we're going to take each point on our pentagon first, and then we might need to find a few more points just to draw the circle. So I'm going to start by we'll take top point, top center point, project down to the original plan, which is horizontal line along here, rotate that onto the new plan. Project from the new plan into the end view. That gives us its depth, and then finally the height of it remains the same because it's not rotating in that direction. So that gives us this point up here for our top point. Going to do the same thing for now on the other points. So we should label them 1, 2, 3, 4, and 5. Point 2 and 5 are both at the same height, so I can project both of them. So 2 and 5 are somewhere over here. Project the point from the original plan into the new plan. This is point 5. Same thing for point 2. I'll come back to that. I'm going to do 4 next just because it's closer and this compass. So point 4, and then point 3 again the same, so from original into the new one. Three and then 5, sorry, point 2. So that gives us enough points to find the pentagon. It doesn't give us enough points to draw the arc or the circle convincingly. We could draw one, but it wouldn't be very good. So you're better off finding a few more points. So some of those might be taking this point down here at the bottom. That's a decent point to take. and you got these points here and here. So there are additional points that would be of benefit to us. And then we might look at other points in between the two here. So we'll label this point A, there'll be one there in the middle, C, there'll be one here, and E. So A and E should both be at the same height. So taking point A and E, they're both at the same height. So horizontally into over here somewhere. And now we just need to locate each of those separately. So taking point A, projected from the elevation into the plan. From the original plan into the new plan, and then project that into the end view. That's point A here. Point E is done the same way, projected from the elevation into the original plan, from the original plan into the new plan. That's point E. C, same idea, so this is the height of C, project that across. We already have its position because it's on the same line as 1. Goes down across up here. This is point C, and then probably just need 2 more points. Like we have enough points up here, but this space here is fairly lacking in points, so we could take one. It doesn't necessarily even have to be at 60-30 degrees, but it's kind of a nice midpoint on it, or you could just draw a line through the middle. So that's point B and D. The height of them are going to be the same. That's why you use the same angle, because you get it's one line across rather than doing 2 of them. So then taking this point from the elevation into the plan, original plan, into the new plan. So this gets repetitive, it's the same thing over and over, moving a point from one view to the next view to the next view after that. That's D, and B now as well. From original plan to new plan to the end view. And then that gives us this point here, point B. So that gives us enough points to draw our curve. So we have the 5 points that are part of the pentagon, and then 5 additional points just to make sure that we have enough information. Then drawing the best curve that we can that's touching off of all of these points. So it should end up being elliptical. And that is this question completed. It is the 2014 higher level question 2.